All right, what's going on, y'all? Today we have another memory forensics challenge from CyberDefenders. So let's go ahead and jump on into it. What is the SHA-1 hash of the image? You can see I already went ahead and downloaded and extracted the information. Now we can just do SHA-1 sum triage memory. While that's doing that, what is the volatility profile? Here we go. Ooh, ooh, there we go. I learned how to copy and paste. All right, volatility profile. For that we can do first, let's set up our environment. I don't know if you know about this, but with the older version of Volatility, which I think is the better version of Volatility, you can export environmental variables. So you can tell it volatility location, give it the location of the memory dump. That way you don't have to keep typing it out for every command, which I think is lovely. Desktop. There we go. And then we can do vol image info. All right. So image info works by examining the kernel debugger data of the image, right? But a thing to keep in mind and what might cause image info to fail is that this data can actually be manipulated on the original system and not affect how it functions and processes. So there might be some malware, or maybe the threat actor is intelligent enough to know that, and they manipulate the data and it might break your image info. If that ever happens, Volatility has a built-in plugin called KDBG scan, and it will give you the same information. It will also give you a little bit more information about the system, telling how many processes are running, how many kernel modules are loaded, so on and so forth. All right, as you can see, we're running a Windows 7 Service Pack 1 64-bit image. And now let's go ahead and jump on into it. But first, we need to give it the profile. If I can spell profile. There we go. All right. For that, we can do PS tree, and we can go ahead and grep for the process that we need, which in this case is Notepad. And we see that it has a process ID of 3032. Now we need the process ID of the child process, the PID for WScript. And if you're curious how PS tree and PS list work, since they're essentially the same command, right? What they do is they look for the give me a second, I can't think and type at the same time, but they look for the active links, active process links. And here is the child process of WScript. The active process links, which is a doubly linked data structure, right? And really what that means is if there was some information that was hidden or terminated, we wouldn't be able to find it with PS list or tree, but we could find it with PS scan. And it'll even give you a whole extra column saying time exited. And you see we would find a process that wouldn't show up on our process tree, right? This Office CR2 client, right? Anyways, the more you know. All right, what is the IP address of the machine at the time the image was created? For that, we can do netscan. We can't do connections or sockets with a Windows 7 with the image that we have now, right? So we can also go ahead and do grep for established connections. The -I is going to ignore any case sensitivity because normally established is in all caps. All right, and we get a few back, a couple Outlook ones, and here we see our sketchy looking process or executable. This first column, or third column rather, right here is going to be our local machine IP address. This is the one the question is asking for. We can go ahead and submit that. And based off the infected PID, which is the attacker's IP, that's probably going to be this one. This column is the foreign IP address. And another thing to consider, you see that the port here being used is 4444. By default, the Metasploit framework, which is a pen testing, red teaming tool set, by default, their exploits will create a callback to the attacker's machine on port 4444. So some more sketchy stuff, essentially. All right, how many processes are associated with the VC runtime DLL? To find any DLLs being used, we can use DLL list. right? And we can go ahead and grep for, just in case, grep for VC runtime, which is a DLL associated with Microsoft Visual Studio Code. And we can go ahead and make bash count for us. And we see that there are 5 processes running, right? So we need to dump the infected process and get the MD5 hash. To do that, we can do proc dump. The -u is going to tell Volatility, we get it, it's probably unsafe, just go ahead and dump it anyways. The process ID, which was something. Give me a second. I want to say it was 34 something. 3489 or something. 3496. So proc dump, PID, unsafe actions are cool, and we're going to go ahead and dump it to our current working directory. Then we want to do MD5 sum executable, and we get this value here. What we can do afterwards, if this was a real investigation, is come into VirusTotal and scan, or rather search for that hash, and we can see that we confirm that this is the malicious process, and the original name, I guess, was ab.exe. All right. Anyways, what is the LM hash of Bob's account? For that, we can do a hash dump. It's a built-in plugin that can easily give us this information. Metasploit can do the same thing. If you've never read this information before, that first column, it's going to be, the columns are colon delimited, as you can see, but anyways, the first column is going to be the username followed by the user ID number, and then we're going to get the LM hash, which the LM hash is the LAN manager hash, and it was used for older methods of authentication over a network. And then this fourth column right here is going to be the NT hash. All right, what is the memory protection constants for the VAD node? This. And what they're asking for is, what is the read, write, and execute attributes for this VAD node? And what VAD is actually really cool. It's more or less an address book for a process's memory segment. And VAD stands for virtual address descriptors, right? And it's going to contain a lot of information, the number of pages, obviously the read-write protections, so on and so forth. So we can go ahead and grep for the node, and we will print 10 lines after. And here you can see that the memory area is read-only. What is the protection for these guys? And what's really cool about VADs is it'll show you, you can dump it out to, so we have VAD info obviously in VAD dump, but we can also do VAD tree. And you can output this into a dot file format, and it's going to give you a nice little graph, and it's actually going to color code the boxes. And if you were trying to investigate a malicious process and you were curious about what that process was writing to the heap, just by looking at the graph that it produces, any of the boxes that are in red are going to be addresses associated with data written to the heap, which the heap is a dynamically allocated area, region of memory. So, hold on. So when the program runs, it's not going to know how much space it needs for that data, right? So it stores it on the heap, which the heap is, since it is dynamically allocated, it can shrink and grow as needed, whereas anything on the stack is more or less hard-coded. All right, so there was a VBS script that was ran on the machine. What is the name of the script? For this, we can come into the command line processes and see what's here. We're going to go ahead and grep for VBS. And here you can see what WScript was doing from our process tree. We can see that it's running this sketchy looking VBS script. and an application was ran at this date and time. But out of curiosity, because I don't remember seeing, thought everything was the 22nd. Yeah, you can see that first few dates, tails. The first few dates are all on March 22nd and the last few. So for this, we're going to have to go into what's known as the shim cache, which is the application compatibility cache. It stores a lot of metadata for any file that was actively ran or actively browsed to even, right? But it's not going to be like the master file table, which is going to have every metadata on every single file on the system, right? Just those that are actively being touched, more or less, in one way or another. Another way that we could do it, if you really want to just hang out for a few minutes, is run Timeliner and grep for it, but that's going to take a hot minute. Simcache is the more efficient way of doing things. All right, what is written on Notepad when the memory dump was captured? For this, we can do a memdump. 3032. A memory dump of the process. The -d tells you what directory we want to output it to. The dot means we're doing it in our current working directory. And then once it prints, we can run strings against the image. A thing to keep in mind, though, is that Notepad stores the information in 16-bit format. So if we were to just do strings, right, and then grep for, flag caret, it's not going to return anything. However, if we add the arguments tech el and tell strings to do 16-bit, you can see that we get our flag. All right, what is the short name of the file at record 59045? For this, I mentioned the file master file table. That is what we're going to be looking at. Parser. We are going to grep for record number 59045, and we want to print 20 lines after. And the master file table contains metadata information on every single file on the system. If there was anything created with an alternate data stream, that information should be discovered there. I'm not 100% sure. I'll do more research and tell you in a later video or in an article on Medium or something. But anyways, here you can see the short name, this employee -1, and the full name of the file itself was employee information.xls, it looks like. All right. And then this box was exploited and is running meterpreter. What is the infected PID? We already know the infected PID because it was the process that we submitted to virus total, right? And that's how you get through it. And if you want to try this before I leave you, if you want to try this challenge using Volatility 3, I don't think Volatility 3 has a way to where you can store the file location in a environment variable like what we were doing earlier. So you have to specify where the file is with -f, and then obviously the syntax for the command, the plugins, is different as well. It's going to be windows.pstree, for example, pstree, which some of them you need the third column or extra column. Some of them I don't think you need it. Yeah, like pstree just goes ahead and prints. However, if we wanted to do mft parse or scan, that one needs it too. All right, never mind. Like I said, anyways, that's kind of a brief showing you how to use Volatility 3 if you were curious about it, because I feel like the standard practice is to use the older Volatility 2.6.1, which I recommend that you just use anyways, but I will say Volatility 3 is significantly faster. However, with some of the older images, the output isn't, it gets a little jacked, right? And I think it's issues with Unicode to ASCII conversions. But anyways, regardless, that's my assumption at least. But anyways, I hope you all enjoyed the video and learned something from it. Please like and subscribe.